Okay, so we're going to talk about sedimentary rocks now. Sedimentary rocks are rocks that formed from the compaction and cementation of sediments or small pieces of rock. For example, sand. The Grand Canyon is full of them, which is why it's pictured here. They can also form when water evaporates, leaving mineral crystals behind. Those mineral crystals are called precipitates. We'll go into a little more detail on that later. So you see sand, sediment, or what's left behind after water evaporates. You can find the processes that form sedimentary rocks on page 6 of the reference tables in the rock cycle diagram. Here's our sedimentary rock and the arrows pointing towards it. So we see uplift, weathering, and erosion. We see deposition and burial, compaction and/or cementation, and then erosion again. The cycle can continue. So to give a quick description, right, rocks are broken apart, broken off from other rocks by wind or rain or snow, ice. The elements break a rock apart, and then that rock is carried away from wherever it was somewhere else. So that's the process of weathering. The rocks get broken down, and erosion, the rocks get carried away and moved somewhere else, again, often by wind or water or a glacier. Then they get dropped off somewhere. So a river might carry sediments to the ocean where they drop off into piles. Sometimes then plants and animals also die and end up in those same piles. Layers of sediment form, and over time the bottom layers turn into rock. So definitions of these processes are here. Feel free to pause if you'd like to write them down. All right, there are two types of sedimentary rocks. One type is clastic. Texture is clastic. In these, the rocks look like how you would imagine a sedimentary rock would look. They're made from pieces of sediments. You can tell a lot about where a rock has been based on the size and shape of its sediments. Another type of sedimentary rock is crystalline or bioclastic. Crystalline sedimentary rocks are the result of solids that are left behind after water evaporates. There's two words that might come in handy here: evaporite, which means the same thing as precipitate. Those are the minerals that are left behind when water evaporates, leaving behind rocks like this one pictured. This is rock salt. So the salt's in the water evaporates, leaving the salt behind, leaving this sample of rock salt. Bioclastic rocks are made by organic things like shells and other marine organisms. They can also be made of plant remains. Anytime you have things that are living in the actual rock material, we call it bioclastic texture. So you can find that information in the chart here: clastic, crystalline, bioclastic, and then there's the one that could be either crystalline or bioclastic. So quick side note, the map symbol over here on the right side shows how scientists represent rocks on a map. It's not a drawing of the rock itself. So some of them look a little bit like the rocks, but other ones don't. For example, there is no rock that looks like little tiny bricks stacked up together. That is just the symbol for limestone. So clastic sedimentary rocks, the top half of our chart, are classified by the size of the sediments in them. We call that the grain size. So you can see grain size listed as the second column. So we have 3 different types of rocks here, each having a different size sediment in them. So for example, sandstone has pieces that we call sand size. So the actual measurement of that piece is listed right below the word sand. Silt stone is made up of silt-sized particles, and so on and so forth. The chemically formed sedimentary rocks are a little bit different. They're classified based on what they are made of. So in this case, the grain size does not matter. It's not as important. More important is what it's actually made of. So for example, the top picture of rock salt, the composition is halite. For a limestone, the composition is calcite. So the minerals that dominate those rocks determine what we name them. So to summarize, clastic rocks are all about grain size. Crystalline and bioclastic rocks are all about composition. Because sedimentary rocks are formed from compaction and cementation, and because things living near and in the world often end up also dying and becoming layers in the earth, that you can often find fossils in sedimentary rocks. Igneous and metamorphic rocks are just too hot. Anything that can melt a rock, anything that can change a rock due to heat and pressure will likely destroy a fossil. So we can also learn about where a rock has been, the rock's story, from the actual grains in the rock, from the sediments and the materials in the rock. So, for example, a conglomerate is made up of different sized particles that are rounded. So it says that on the page 7 chart in the reference tables. What I know from those large rounded sediments is that conglomerates are usually formed at the end of very fast moving rivers. So why do I know that? Well, the large pieces mean a fast water. They can't be carried by a slow moving, trickling little stream. So it has to be faster water. And the rounded particles mean that they traveled a long distance. The particles, the sediments will just bump and bounce against each other and roll along the bottom of the stream. And as that happens, they'll get more and more rounded the farther they travel. So longer distance, fast moving water forms the different size pieces in a conglomerate, and we can use those features to tell us about the rock. A sandstone, on the other hand, is made up of sand-sized particles, sandy texture, gritty feel. Environments that might form that include beaches, sandbars, deltas, dunes. So different types of environments than what would form a conglomerate. So that's a summary of sedimentary rocks.